Question number 5a. So it says, let the function f be defined by f of x equals e to the x cos x. And part A asks, find the average rate of change of f on the interval. So it's important to not mistake the average rate of change as the average value. Although they're both related to the mean value theorem, the average rate of change is just the secant slope, or the slope between the points x equals 0 and x equals pi. And part B is asking for what is the slope of the tangent line at x equals 3 pi over 2. Tangent line is going to be the instantaneous slope, so we need to find the derivative. Okay, so we don't want to, for part A, we don't want to do average value. We want to do average slope, or the slope between 2 points. And for part B, we're going to use the derivative to find the instantaneous slope. So for A, the average rate of change, or the average slope, is going to be equal to f at pi, the y value of pi, minus y value of 0 over pi minus 0. So we're just calculating the slope between those 2 points. F of pi, when I plug pi in, I end up with e to the pi. The cosine of pi is -1 minus f of 0, because e to the 0, the cosine of 0 is +1. And the run is going to end up being pi. So the average slope, when we calculate this out, is going to be negative e to the pi minus 1 over pi. Okay, so that is my average slope. So if we were to take a look at the graph of this, the graph of this looks like this. In blue is our f of x function, and the average slope is going to be the secant line, or the slope between these 2 points. So we're just finding the rise and run between those 2 points. Okay, so this is our delta y and delta x that we calculated. Okay, so for part B, we are going to find the tangent line slope, so we need a derivative. So for part B, we're going to find the derivative. So we need to differentiate this expression. F prime of x, because it is a product, e to the x times cos x, we need to make sure we apply the product rule. So the derivative of the first term times the second term undifferentiated plus the first term undifferentiated times the derivative of cos, which is negative sine x. Okay, so just the e to the x looks the same in both terms, but one is a derivative and one is the original function, because the derivative of e to the x just happens to be itself. So we're going to just simplify this expression. I'm just going to factor out e to the x. And then we have cos x minus sine x. Okay, so when we find the instantaneous slope, we find the derivative value at 3 pi over 2. So plugging in 3 pi over 2, we get e to the 3 pi over 2. The cosine of 3 pi over 2, so if I take a look at where the cosine values are at 3 pi over 2, just look at the unit circle. 3 pi over 2 is here. The cosine value is the x positioning, the horizontal positioning, so that's going to be 0, minus sine is at 3 pi over 2 is the y positioning on that point. That y positioning is going to be -1. So this works out to be 0 minus -1, or +1. So the slope value works out to be 3 pi over 2. Okay, so that represents the slope of the tangent line at that point. Again, if I take a look at this graph, there's my the red line represents the slope of the tangent line, or that represents the tangent line, and that slope value is e to the 3 pi over 2. When we look at the marking scheme, for part A, we get 1 mark just to calculate the slope value between those 2 points. For part B, 1 mark is for the derivative, and the second mark is for calculating the value of the slope when we plug in 3 pi over 2.